Oh no, lights are out, but I still have power. How is this possible? My power is uninterruptible. This box is filled with lead and acid, and we've got to have a deeper conversation about backup batteries, UPS, uninterruptible power supply. No one likes UPSs, and I think the reason for that is people buy a UPS and expect it to last forever. It won't last forever. But also they buy the wrong kind of UPS, and then are frustrated with the result. But wait, there's more. More power! But Wendell, you say, you're out of breath from schlepping around a 300 pound, it's not 300 pounds, but a super heavy 2U rack mount UPS. This is for my tie-in transport 2U. It's a 4-node EPIC cluster in just 2 rack units. You might be saying, I don't want rack mount. I want something that's a little bit more friendly. Well, don't despair. You don't have to deal with a rack mount UPS. You can get a desktop UPS. Yes, this is much more reasonable. This is 1200. It's a 1200 rating. That's a 1500 rating. We'll talk more about that. You know what gets my attention on the box? Pure sine wave power. And it mentions gaming computers because people don't know. And then it talks about RGB. Detachable wireless LCD operates for up to 20 feet away for 12 hours. So in the box you get the UPS and a USB A to B cable so that you can plug this in. Now this is not your grandfather's UPS because it has a detachable LCD screen which has its own battery, and so you can monitor the status of your UPS wirelessly. Now with 75% more fresh batteries. This is from Tripp Lite. It's the Smart 1200 GSLPR LCD something. It's the gamer version of the 1200 LCD. It's more than just a souped up power strip. Do you need an uninterruptible power supply? Well, I think you do, but it's a little more complicated than that. It's not just for your computer. It could be for your console, your TV, electronics. Basically anything that you want to protect from power surges and other things that may be weird with the electrical power provided in your place. You see, power going out isn't a huge problem in and of itself. It doesn't tend to murder your electronics if you just lose power. It's basically like yanking the cord out of the wall. But you know, generally, that is the least likely scenario to murder your expensive electronics. You just yank the cord out and it turns off. You probably already have a surge protector or something like that on all your expensive electronics anyway. I mean, that goes without saying. You never know what can happen with the power. What actually triggers power surges and causes the power to go out is not usually just somebody tripping over a cord somewhere. Somebody hits a utility pole, a telephone pole that has power lines at the top of it. It can yank the wires and short things out. When it shorts it out, that's going to cause a massive power surge because at first the power grid thinks, oh, I need to provide more power, something has come on, and then it's like, wait a minute, this is a short, and it turns off. Lightning strike? A lightning strike can also cause massive power surges. So if those things happen and you don't have a surge suppressor, it's really bad. Oh, solar flares? The last couple of months, we've had crazy amounts of solar flare activity. It's off the scale. It's much higher than predictions that we've had, quite a bit higher. So the solar flare activity right now, really not great. One of those solar flares is directed towards Earth. Turns out our power grid is dangerously fragile. A UPS probably won't save you if we have another Carrington event. That was when there was a solar flare that was so bad in the 1800s. The people that operated telegraphs, which is basically the only long-distance wiring we had at the time, were electrocuted, and their telegraphs caught on fire because of the induced electromagnetic current, which is sort of bad. This won't help you with that, but we do have solar flares, and those encounter the grid, and sometimes those cause power surges. Just regular solar flares, not Carrington event-style solar flares. So this could protect you from those. I mean, that's a thing that could happen, maybe, possibly. That's just the regular scale solar flares. Brownouts. What about, changing the topic? Brownouts. What about brownouts? There's brownouts in a lot of places. If you're in California, you're probably no stranger to brownouts in other parts of the world. That's when there's too much demand on the electrical grid, and the power level sort of drops, and the voltage is not what it should be, and the power output is unclean. Yeah, the lights dim and flicker. It's kind of a visual manifestation for you of the awful, dirty uncleanliness of that power. If your lights are struggling to do that, it's like, how did this white light turn brown? Well, for your electronics, that's like drinking tepid rust water from the bottom of an abandoned well. It's not very good for your electronics. A UPS can sort of solve just about all those problems, or at least address them in varying degrees of success, depending, of course, on the quality of the UPS and a bunch of other factors. But hey, we can start the conversation. Think of the UPS as filtering all that brown, rusty nastiness out for you before it ever reaches your machine. If UPS can protect you from all this, why don't we see more UPSs used in the wild? Well, the reality is that we do. The old telephone system, it's probably one of the most well-protected pieces of infrastructure that we have in America. That thing has, 30-year-old battery solutions that keep the phones working even when there's no power. It's probably even more resilient, at least it used to be, than our power grid. We've neglected it, and it's probably our own short-sightedness. But for servers and telecommunications equipment and basically anything that's important, UPSs are everywhere. But consumers don't really like UPSs. We're lucky in America if your average American home has a pair of properly installed grounding rods. That's how sort of bad a lot of the electrical situation is in American homes. And you really need proper grounding rods in order to protect your expensive electronics and surge strips and everything else. So anyway, how do you pick the right UPS then? Well, it's not really as straightforward as you think, because the water's become a little muddied. It's not just about things, and if you've ever bought a UPS in the past, it's probably been a frustrating experience because you probably bought the wrong type of UPS. Probably wasn't great. And one of the reasons that I'm doing this video is because I'm actually really frustrated trying to find an appropriate UPS for my relatively high-end Threadripper desktop system. There's a kind of no man's land of backup batteries between this and something for an even higher end system, like my Threadripper machine. But we're probably going to cover that a little bit more in detail in another video. I mean, sure, I've got a 1200 watt power supply, so this Smart 1200 UPS, is that 1200 implying that I should be okay with a 1200 watt power supply? No, it turns out the answer is no. Now, this is perfectly fine for your average gaming desktop, even a gaming desktop that's rocking something like a 3090, but my Threadripper system's a little something special. I've got something, something in mind with that. But let's start with the types of UPSs that are available, because it's more than just the wattage, and it's more than just the VA rating or the number that's in the name. The anatomy of a UPS is, well, there's a big battery or something to store energy. I can't say battery because there are UPSs on the market that use a giant kinetic flywheel. Yes, basically a concrete filled spinning wheel that's kept spinning because of power applied to it, and when the power goes out, that turns into an electricity generation mechanism. Kinetic UPSs really are amazing, and more power to you if you can afford one of those for your home installation. There's also the part of the UPS that turns that stored energy back into electrical energy that is appropriate for the devices that are plugged into it. Alternating current, most of the time. Devices plugged into a UPS are not built to tolerate something weird happening with the input power. We see stuff on the level 1 forums all the time where somebody's got a marginal power supply and it's like, hey, when we turn the vacuum cleaner on, my computer locks up. And it's like, yeah, machine crashes. Yeah, that can happen. If you've ruled everything out and your machine still crashes weirdly, it might actually be because your input power is crappy, nothing to do with your power supply. The power in normal electrical outlets is alternating current, or AC, and it's typically 110 volts here in North America, or 220 volts in a good part of Europe. What AC means, or also implies, is that it also follows a sine wave, alternating from positive to negative voltages. This is something that's really important to understand because it doesn't mean that you can just cleanly cut over from one power source to another? What if it was in the sine wave in a different place? That could actually cause problems, and the UPS should be built to deal with that. Not all of them are. So as for UPS types, the first one is a standby UPS. Standby UPSs basically have a kind of dead man switch in them, so when the power cuts out, the switch closes and it switches to battery power. This is not just a standby UPS, but you hear a fan and some machinery kick on the inside. It's got 12 to 24 volts on the inside. This particular one I think is 24 volts, and it's going to take that battery power, which is DC, convert that up to 110 volts, and splice its artificial sine wave into the real sine wave that was there when the power was lost. Wall power can vary hugely in quality. Now this is an ancient UPS. It takes alternating current. It's got 2 outlets on the end. It says that it's backup 650, but this thing is actually a piece of crap. It doesn't even output a sine wave. This is the type of UPS that you would find for telecommunications equipment about 20 years ago, but mostly you don't see this kind of UPS anymore because a lot of modern power supplies will not tolerate anything other than a perfect clean sine wave output. So this is a standby UPS that is just a standby UPS. The other definition is line interactive UPSs. It's a standby UPS with a much better electronics package, and that does a good job with managing the sine wave output, and it'll even try to synchronize its sine wave output to the line output a lot of the time, not always, but generally, before the input power completely disappears on its way out. And often, but not always, the line interactive UPSs can compensate for something like a brownout in a lot of brownout scenarios without even having to hit the battery to do so, which is a pretty big feature. And finally, there are double conversion UPSs. They're the best because they take the input power and they always run the input power through their power conditioning circuitry. So whatever they've got for voltage regulation and everything else is always on. It's always active. Those UPSs usually have a fan and they're usually pretty big. They're not conditionally conditioning the power. Conditionally conditioning the power? Yes. Our Tripp Lite UPS here conditionally conditions the power, meaning that if the input power is good, it doesn't touch it. It's only when the input power goes bad that it takes over. So it's designed that way. So double conditioning UPSs, sometimes these are referred to as online UPSs, meaning that they are always online doing something with the power. They're the best because their circuitry is never off. But they're also, that's an efficiency cost. They're going to produce heat. They're going to wear, and so they're going to cost more. They're going to be higher end. And, this old UPS is 20 years old, and we've come a long way since then for more modern UPSs like the one from Tripp Lite. So there's really not as much difference between a good line interactive UPS, which is, the standby UPS on steroids, standby UPS with some special sauce, versus truly, double conversion UPSs. As far as we come, though, there are still some frustrations dealing with UPSs. One of them is ratings. You have to take the UPS ratings with a grain of salt. Just about every time. It implies that you're looking at a wattage, and that's because a lot of the time the wattage estimate of your computer is an overestimate. But if you know what you're doing, then it's not an overestimate. So my threaded per machine, 1200 watt UPS, it's using 1000 watts at the upper end when it's really busy. You would think a UPS labeled 1200 or 1500 will be sufficient. It's not the case. And this is the no man's land. There's 1200 and there's 1500 UPSs, but functionally there's not really a huge difference in wattage there. It has to do with how quickly it can dump its load. All of these UPSs that I'm showing you are using lead acid batteries. I mean, there are lithium ion battery UPSs, again, at the higher end, and that's fine. But lead acid, it's a cheap, proven technology. It's a reliable technology. And a UPS is really only meant to last 5 or 10 minutes. It's not like your laptop where it's going to run down in an hour. So the lead acid battery has to be able to dump its entire load in, 5 minutes, 10 minutes, a couple of minutes. That is a lot of energy to be dumped through the battery and the circuitry in a very short amount of time. And the faster the battery discharges, the shorter the operational lifetime of the battery. In other words, the faster that lead acid battery is dumping its load, trying to keep your stuff online, the harder that is on the battery, the fewer recharge cycles you're going to get out of it. So my 1200 watt threaded per system, I pretty much have to go into commercial level UPS territory, 2200 and beyond. in order to be able to support that. The other bad news is that the batteries in your UPS, they'll only last 2 to 3 years, even under ideal circumstances. Now, you can perhaps, buy yourself another year or so of battery lifetime if you size the UPS such that you're really only using about half the capacity of the UPS. That's because that when it has to do its work, it's going to discharge at a much slower rate. That's easier on your batteries. And it is possible to replace the batteries in your UPS for a lower cost. Our Tripp Lite UPS, for example, has removable, replaceable batteries. So you can get, 6, 9, 10 years of, usable lifetime out of this, replacing the batteries once or twice, depending on what you do. Danger, Will Robinson. These UPSs would just as soon murder you as look at you funny. So don't take them apart. You have to check the manual and see what it says for replacing the battery. This particular model was notorious for murdering people that open the end of it, or so I've been told. There's a door on the bottom for the battery, and some people were like, I need to replace the battery, and they didn't look on the bottom to see, oh, there's a battery door on the bottom. They would take the sides off, and the battery, keeping the thing charged, that's just a little murder machine. Your heart stops and then you die. So if you're going to do that, you've got to be extra careful when you replace the batteries. Now the batteries themselves, those are direct current. They're not dangerous. On this particular model, there's 2 screws on the bottom. You take that off, you slide this. There's a red safety wire. You pop that, and that disconnects the batteries. If you want to be paranoid, let this thing sit overnight after you've disconnected the batteries before replacing the batteries. Oh, and this should be off and unplugged while you're doing that. You don't really have to be that paranoid, but, full disclaimer, if you don't know what you're doing, don't do it. And I didn't tell you to do it. And other legal disclaimers, keep that in mind. Just be aware of it. That said, you can sometimes buy a UPS that has bad batteries and then have a nice UPS for the cost of putting batteries in it. But if you see a UPS like this, it's so old, just let it go. You don't... There's been so many gains since this to that this is just not worth it in any equation. None. 0. Makes no sense. Don't do it. So let's take a look at this model from Tripp Lite and see what kind of a runtime we're going to get on a high-end gaming PC. But I have a feeling that the runtime for pretty much any Smart 1200 is basically going to be the same, whether you get the gamer version with the RGBs or not. They added RGBs to a UPS, an uninterruptible power supply. Well, they also improved the charging circuit. They tell me that this thing is going to last about 2 to 3 years, plus or minus, under ideal circumstances. It's not terrible. So how do we determine if a UPS is doing its job right? How do we determine if it's a good UPS? Well, we can do that with an oscilloscope. So it turns out that the 12-volt rail in your PC power supply is what does most of the heavy lifting. The 12-volt rail is the most important one because that's where most of the power for your GPU and your CPU comes from. It's pretty crazy if you think about it. Under the heaviest loads, you're consuming 5 to 10 amps at 120 volts from the wall, but that gets transformed ultimately into hundreds of amps, just over 1 volt for your CPU. Yeah, I mean, your CPU is 1.2 volts, 1.4 volts, but the same wattage, so just an ungodly number of amps. And the same thing is basically happening for your GPU, although over perhaps a wider range of voltages. So here, if we take a look at it under the oscilloscope, we can see the 12-volt rail fluctuating a little bit as I start and stop various benchmarks. So that's pretty normal. You don't want a huge amount of variation here. But when the devices ramp up, the power supply has to provide more power on the 12-volt rail. And so there's a little bit of a lag time in how it responds to do that. So as you can see with our benchmark running, we're kind of getting the upper limits of what a UPS like this is capable of. Yes, this is a 12400, but honestly a 12900 is not going to make that much difference. You might go from 6 minutes of runtime to 4 minutes of runtime. And this is why my Threadripper system needs a little something more. The power supply itself really is sensitive to the input power as well. So when you have a UPS and you switch from mains power to the battery power, there's going to be a little bit of a glitch there when it does the switch over. And if your power supply passes that through to the 12-volt rail, that can introduce instability. So these line interactive UPSs do a pretty good job, and we can see that on the oscilloscope. Now, of course, if you had the double conversion or online UPSs, those would do the best. Those are pretty much impossible to tell where they cut over to battery. But for standby UPSs, you can kind of see where they cut over in the 120-volt side of things, and sometimes that'll translate to the 12-volt rail. But here's where there's a little bit of a variable too. Your power supply has capacitors and has internal circuitry. Some power supplies will tolerate this kind of cutover more than others. Some won't. So it's a your mileage may vary situation. The UPS has to do as good of a job as it possibly can do to try to make sure that your power supply won't notice. But the reality is most modern power supplies don't really notice. In fact, if you've got an Xbox console, Microsoft designed the power supply, like the Xbox 360, I know this is true, I'm not sure if this is true of the One S. They overspec the power supply so hardcore that when you pull it out, if the console's at the menu screen or something like that, it'll actually keep running for a second or two after it's lost power. That's the residual charge in the power supply. And that's because when the console is super fully loaded, it goes from not using a lot of power to using an enormous amount of power in such a small amount of time that the power supply is really what has to respond, because the wall outlet, the mains, can't respond quickly enough to the increased power load. So I'm oversimplifying things, leaving out a lot out of there, but basically that's what's happening. So it's a really, really interesting situation. So with our open air gaming system, this has got the i5 12400 in it and the 3090 Ti. You can see the runtime from our Tripp Lite backup power supply. Not bad. Definitely it would be my advice that if you're spending hundreds of dollars on your CPU and hundreds or $1,000+ on your GPU, a battery backup of some type of uninterruptible power supply is a relatively modest investment. Just keep in mind that you're going to get 2 to 3 years out of it. When you've gotten your 2 to 3 years out of it, what does that failure look like? Well, it can actually just turn your computer off at random times. You see, it'll put the battery through regular automatic testing, and if the battery fails, the whole thing would just turn off. And that can actually be really hard on your machine. Usually the LCD screen on the UPS will give you some kind of an indication that that has gone wrong, and you should worry about that. The software can also include options for doing testing and telling you the results of the testing and letting you know. And if you do pick up one of these, I would recommend you letting it charge overnight. They're typically shipped half charged or a third charged, something like that is what you'll see when you unpack them. So before you plug any equipment into them or anything, plug it into the wall, let it sit overnight, and then actually attach your stuff, install the software, and go from there. Now I've got a couple other videos coming up. We're going to take a look at that rack mount UPS in the context of our 4-node EPIC system, and also this mighty UPS for my Threadripper system, which, spoiler alert, ooh, that's nice. Alright, I'm Wendell, this is Level 1, I'm signing out, and you can find me in the Level 1 forums.